quotients of complex numbers. So we also have a formula for finding the quotient of two complex numbers. If I have a number r1 cis theta 1 and I want to divide by a second complex number r2 cis theta 2, simply divide the moduli and subtract the arguments, top minus bottom. Let's put that into practice. I have 10 cis 13 pi over 18 divided by 2 cis 5 pi over 9. According to the formula, all I have to do is divide out the moduli. 10 divided by 2 is 5. And then for my new angle, my new argument, I'll be subtracting 13 pi over 18 minus 5 pi over 9. Let's see, I'll have to get a common denominator there. Multiply top and bottom by 2. So that's going to end up being 13 pi over 18 minus 10 pi over 18, which is of course 3 pi over 18, but that reduces to simply pi over 6. Here is the trig form answer to that problem. If I wanted the rectangular form, I would just have to write it out the long way. 5 parentheses cosine pi over 6 plus I sine pi over 6. And then calculate those values. We've done these so many times. Cosine pi over 6 is square root of 3 over 2. And sine pi over 6 is 1/2. And when I distribute the 5, it looks like I'll get 5 root 3 over 2 plus 5 halves I. A plus BI. So I've written my number in standard form. For the second example, I'm going to have to do a little bit more work in order to use my formula because the two numbers I've been given are in standard form right now. Again, there are methods for working directly in standard form, but our purpose is to switch to trig form and use the formula. Let's draw a couple of quick pictures here to help us. 1 minus I, so real part of 1, imaginary part of negative 1. This looks pretty easy. This is obviously a 45, 45, 90 triangle, which means I know this is root 2. I am in the fourth quadrant. If the reference angle here is 45 degrees, that of course means this big angle is 315 degrees. I think I'll work in terms of radians, so I'm going to rewrite this problem. I now know the top part is square root 2 cis 315 degrees, or in radians that would be 7 pi over 4. For the bottom number, I'm going to need a picture there as well. This one's even easier. 1 and 1, I'm just in the first quadrant. Again, it's the same triangle. So obviously the angle is 45 degrees and the r, the modulus, is square root of 2. And so my trig form would be square root of 2 cis 45 degrees, which of course is pi over 4. Now that both of these numbers are in trig form, I can go ahead and use the formula. I am supposed to divide the moduli. Root 2 divided by root 2 is 1. And then I am to subtract the arguments. 7 pi over 4 minus pi over 4 would be 6 pi over 4, which reduces to 3 pi over 2. I certainly don't need that 1 sitting there. And so my final trig form is just cis 3 pi over 2. And of course, if I want the answer in standard form, I would just write it out the long way. Cosine 3 pi over 2 plus I sine 3 pi over 2. 3 pi over 2 is just 270, so I can make a quick unit circle picture here. That's the point 0, negative 1. The cosine value is just 0. The sine value is negative 1. So when you clean this up, all you have is I times negative 1, which would be negative I. Negative I is the standard form version of our answer. Thanks for watching.